As president of the school board, I feel it is necessary to call roll call. So, President Jonathan Landemore.
Here.
Superintendent Austin Van Truin.
Here.
And President of the school board, Lloyd Sider. Here. All right, let's get this meeting started.
Okay, well, as principal, our chemistry teacher is up for tenure, and he submitted the video, so we should just watch it, start off with that.
Let's do it.
I'll get the lights and I'll start.
Alright, settle down, class. Settle down. Good afternoon, Central AP Chemistry. Central Hunterdon. I am your professor, Professor Hackett, and today we will be starting with one of the most simple of the chemical processes, perhaps one of the more ubiquitous ones. We shall be starting with distillation, spelled like such. Now class, is there anything that you'd like to know about distillation before we begin? Yes, you. Joshua?
What purpose does it serve?
You see, that's a very intriguing question. Perhaps a very simple question, one that I will answer. Distillation, at its heart, is the process of separating different chemicals or substances based upon their physical properties. The physical property, in this case of separation, being their boiling point. Next question.
How is it made?
I'll try to answer to the best of my abilities. Distillation is a process that requires much equipment, and essentially you have the combination or solution of substances, and you add heat to it until you reach the boiling point of one of the substances. At that exact point, and no higher or lower than the first boiling point, you will change the substance. It will change state. Let me try to explain it to you in a better way. Let's say that you have substance A. Substance A is at 70 degrees Fahrenheit. Substance B is at 80 degrees Fahrenheit. If you added heat to the mixture in the distillation chamber until you were at 70 degrees Fahrenheit, you would separate the two substances based on their physical properties, which is their boiling point. At this point, the temperature will not change to 71 degrees until all of substance A has been evaporated, giving you two pure substances. Next question. Yes, you, George, in the corner?
Yeah, I got a question. Could you explain the chemistry?
I am a chemistry teacher. Let me try to explain it to you. The changes that occur are not chemical changes per se in all situations. They are more like physical changes, because the substances themselves should not be changed. The reason why you want to distill substances is because you want to purify one of them, or all of them, into their pure, unadulterated state. Chemistry is just essentially the forces between the liquids changing to the point where they have so much energy that they change state into a gas. When it changes from the gas state... Oh, excuse me, sir, can you please turn down your cell phone? Okay, can I please take it? Can I please take that? I need to take it to the office. Give me the cell phone right now.
No.
I don't appreciate your sarcasm right now. Give me the cell phone.
I'll turn it off.
Good. Where was I? Oh, yes. The energy is added at such an amount that the physical properties of van der Waals forces and the other attractive forces are no longer enough to keep the atoms or molecules combined in a liquid state. Next question?
Could this product be improved?
Oh, it could easily be improved. As we all know, the ability for a substance to boil is based not only on the temperature, but also on its pressure. If you were to lower the pressure, it would be easier for you to make a substance boil, thus making a more efficient and easier distillation process. What was the question? How would you market it?
How would you market this product?
If you were to market distillation, it would be one of the more easy things you could do in terms of chemical engineering. Because many laboratories, just like ours, need pure substances to work with. Distillation is something that you could market to any sort of laboratory or scientific group in order for them to receive proper substances for their experiment.
Okay, so that was a video of Alexander Sandleton, our current AP chemistry teacher as well as regular chemistry teacher. First opinions, reactions?
He didn't seem very put together in the video. I mean, he was not completely inclusive of the subject, and I just feel like there's a lot more ground he should have covered.
I did like his vocab and how he used the board to show some of what he was trying to say, some of the models, but it wasn't great.
Let's face it, he needed a diagram, right?
Yeah, he definitely needed a diagram.
That's very true.
I think I know a little bit about the subject.
You do?
Should I put a diagram on?
Yeah, put the diagram up there.
Alright.
Now you're gonna diagram distillation, right?
Distillation.
Because he definitely was missing a diagram. As a student, I definitely would not know what he was talking about when he was explaining all the chemistry.
Alright, so basically you start out with your solution of substances X and Y combined together, and they have different boiling points. Let's say solution X has a boiling point of 50 degrees Celsius, and Y boils at water 100 degrees Celsius, and then you get a source of heat, and apply heat to the solution until the entire solution reaches a boiling point or a temperature of 50 degrees. At this point, the vapors of substance X will become vapor and go through this tube into a condenser, which is usually in the form of a coil. And from there, the coil is chilled with a fan or a cool bath apparatus, and the vapors are condensed back into their non-vaporous form below 50 degrees Celsius in a liquid form, and they are condensed or distilled.
Yeah, I definitely agree with you. You definitely need a diagram when teaching distillation to the class.
Yeah.
Also, another topic that I caught on that he was lacking in, overall though, it was pretty good, but he was lacking in, he didn't mention the uses of why people use distillation. People use it to make a pure substance, such as water from seawater, or to separate alcohol from water to make vodka, for example, or to extract essential oils from plants, olive oil, and to divide crude oil into its different components. He definitely should have mentioned that as a very key component to distillation.
Yeah, that's definitely true. I was just wondering, he didn't explain really any way to better distillation. I mean, there's multiple ways you could better distillation. For instance, you could basically increase the pressure, and that would also increase the separation of the two liquids when the first boiling point is reached to get a more pure substance. And then you could also increase the surface area of the fractional column, which would make it easier to break up the two substances and cause it to have a lower boiling point for the first substance. So those are just two ways he could have explained how you can improve distillation better.
And even further than that, like when you have your final solution, you can't get 100% pure of a substance because there will always be some of the substance Y that gets distilled anyway. So you could use like a charcoal filter to help separate some of the impurities afterwards.
Yeah.
I believe he explained how to market distillation pretty well. I feel like he covered that topic too. I mean, what the students need to know.
Distilled water is a very big resource in the U.S. It's not really heard of much, but people use distilled water for a lot of things. I know my dad uses it in our washing machine, and other people use it instead of normal water because they don't like the taste of normal water. They actually like distilled water, which is a little weird, but anyway, besides the point. But
being more pure, you know?
That's true. Distillation, even in alcohol, beer is made using distillation, so distillation serves a lot of purposes.
Yeah, I feel like he definitely didn't cover that topic well enough. It's used in everyday life a lot. It's commonly used, as I said the uses before. But I don't think this was a good video for him to show us, because right now I don't think we should give him
It's a
tenure.
pretty terrible example of his performance at the school.
So are we all in agreement? No tenure?
No tenure?
I'd like to take a vote. No tenure?
No tenure?
Aye.
All in
Aye.
favor say aye. Alright, it's settled.
Okay.
No
He,
tenure.
no tenure for him.
Alright, well, that was the one thing in our meeting, right?
Yeah, I think that's the only thing we need to cover for this.
Alright.
Okay. Nice to see you.
Pleasure meeting.
Yeah.
Pleasure.
Next month.
Next one.